All right. Hey, hi, everyone. Thanks for tuning in, and welcome to the to Lighting the Oregon Trail in 4 Dimensions today. My name is Bruno Gohier, and I'm a senior technical artist at GameLoft Australia. I'm very excited to be speaking today. In fact, was supposed to be in person, but COVID being what it is, still here. I hope we can meet next year. But in the meantime, I'll be talking about building the custom lighting tool that was used to create 24-hour lighting scenarios that you can find on the Oregon Trail. So just a little bit about me. I've been in video games development for the past 16 years. I've oscillated between 3D programmer and technical artist. As you can guess, I'm a numbers-oriented person, but I really enjoy seeing what visual results can come out of those numbers. So that's what makes me passionate about lighting in games. So yeah, very happy to be here. Now let's start and see an overview of what we're going to see today. So first of all, why is lighting interesting? Well, first, because I think it's infinitely complex, and so for techie people like me, it's always a good challenge to deal with. But also because I think it carries a lot of the emotional content that a game has. All right. So from a technical standpoint, when building custom lighting system, it's very important to choose the lighting parameters and to expose them the way that we expose them. They can either empower people to do great work, or it can discourage them. Okay? So as you may have experienced before, nailing the correct lighting for a project is usually as tricky as defining the whole artistic direction itself. So bad lighting can ruin even the best pieces of art sometimes. So through this talk, I'd like to show you a couple of good practices that we've been putting in our work that help stay clear of the pitfalls, and hopefully you can use those in your own project. So I'll demonstrate how a complex time of day system can expose a lot of parameters. Sorry, I forgot about doing this. While remaining intuitive and easy to use. And also, I will demonstrate how the Oregon Trail team brought to life a vast number of vivid animated skies without getting lost in the configuration details. So to do so, we'll first take a look at where this project comes from. Then we'll see what the mandate we inherited from concept. Then I'll dissect the whole solution for you to see where it could have gone wrong or how we avoided getting into trouble. And I'll show you how the system was optimized as well. Finally, we'll do a little recap of our learnings, and we'll finish with a Q&A session. All right, let's start it off. First, let's go back to the 80s. So the origin of the Oregon Trail was on Apple II. Actually, it was popularized on Apple II in schools for kids to learn about history. So the game is a group of settlers that leave the city of Independence in the American Midwest, and they travel to the coast of the West Coast to Oregon City. And as a player, you're called to make decisions for your party that will decide their path and their faith on their journey to Oregon. The 2021 Apple Arcade, the Oregon Trail, is a modernized version of this game with graphic updates and a better representation of historical facts. So at GameLoft, we were mandated to bring back this title to life by giving it a fresh high-tech look, all the while keeping the 8-bit pixelated nostalgic feeling. So this was achieved by creating characters and interactable props in a pixelated art style, but still rendering the environment with 3D assets and modern lighting techniques. So here are some before and after screenshots to give you a preview of the end result. It's pretty stunning to realize that there's almost 40 years separating those images, right? So very great art that was done in this game. So I'll show you a lot of images because I think it's worth showing. For those who know this game, the Octopath Traveler from Square Enix is presented in a similar style, old versus new, or old meets new, actually. And that was a great inspiration for us, so I just wanted to acknowledge that. But back to sky and lighting, one of the requirements to achieve this was for the art team to be able to create a very wide range of skies, weather effects, and lighting scenarios, and for the design team to be able to tell a story. So this required a tool that would expose a lot of parameters to encourage freedom of creation, but was also crucial to make this tool easy to use to minimize frustration. The tool also needs to be well optimized to preserve performance and offer a high-level storytelling API. So that's what we're going to cover. Okay. Now that we know what we're going to be doing, let's see how we built it. Right? So since the Oregon Trail is presented as a side-scroller, it did not make much sense to use a 360-degree sky dome to render the skies and light the scenes. Okay. Now, don't get me wrong. This game is a 3D. Sorry, this game is a 3D game, and it needs to be lit as so. But it didn't make sense for the artists to. So I had to go back to my slide. Yeah, there you go. Didn't make sense for the artists to use the sky dome. Moreover, design kept asking for very specific looks with precise positioning of the sun and the moon on the screen. All right. For example, let's say the designers say we want the sun to rise on the right side of the screen over a pink gradient background, and then move up to the top middle at noon with lots of puffy clouds. And then we want it to set on the left side with an ocean of orangey purple light. Very great concepts here. These are nice. It made sense right away that we needed a way for artists to define those parameters in a screen space fashion. Okay, meaning that they will define where on the screen it's going to happen. So this means that the artist would be able to directly translate the design request without having to convert them to 360-degree world space, which would have been very confusing and messy in my opinion. All right. So, oops, sorry. Also, one could say that it might be a waste of time to try and please everyone. While this is true most of the time, we'll try to see how this is possible. Okay, so that's a challenge we're gonna try. The challenge we're gonna try and tackle. Okay, so when we build this system, we need to build a system that lets artists define sky and lighting configuration on a 2D canvas for 24-hour period. It also needs to allow designers to smoothly transition between those configurations to build a narrative to the game. And also it needs to be not too hungry, so we keep the team production happy. Now let's dive into the meaty stuff, and let me present to you what solution we came up with. Okay, so instead of trying different approaches, we had a really good idea of what we were going to be doing. So we started with a very simple solution, and we build on top over time. I will dissect the system and help you understand how those three requirements mentioned earlier could be met. Okay, so first we're going to dive in the material that draws the sky, and then we will see how the sky material gets its inputs. Next, we'll go over the parameters that artists work with to bring all this to life, followed by how the system is optimized. And we'll finally see how the Oregon Trail is, the Oregon Trail time of day system is used by design to create a story that the players experience. So first up is our canvas and its material. So as you can see, the canvas is just a simple quad. It positions and scales itself to the frustum in front of the camera. So this is one less task that the artists have to do. Okay, we're just going to let them focus on making things look very good. And the material draws on this canvas. All right. This game was built using Unreal Engine. So for those who are not familiar with this view, this is the main time of day actor and all of its components. The time of day keeps track of the time, and it manages all the components below. The components, they read values set by the artists. They update their own internal values, and then they pass the result to the rendering part that they are driving. So this could be the material itself, or it could be a secondary component such as the fog or directional light. So you can see there's a component for each part of the image and the lighting itself. All right, so let's see a practical example here. We'll start with a unlit scene, and we'll start the process. So the first thing that's going to happen is that the sky is going to draw a gradient on the canvas at the back. Okay, so you can see it's like a dark purple to black in this case. The second thing that it's going to do is going to calculate ambient light, which is going to be used to light the foreground scene. Then we're going to add the stars, so they're blended in. If this was animated, you would see the stars rotate slowly, so there's some life in that sky. Then we draw the moon procedurally. That's a circle with some gradient. The colors, the position, the size, and everything is artist defined. The moon is also talking to the directional light, so now you can start seeing some shadows appearing. Then we're going to blend the clouds in there, and they're going to take the directional light color. And then we put fog on top of all that, blend it all. So with some final post-process like depth of field and everything, this is how we get the final frame. There we go. So that's all the steps that go into building one of those images. So let's see the material now. Okay, so this is a graph that represents the material. The material is similar to a post-process in the sense that it renders the sky elements using mainly the screen UVs. The material is a mix of procedural techniques complemented by texture and curve readings. Thanks to Unreal Engine's ability to create material functions. Okay, those are those little boxes here. They contain, each of them contain a bit of code. So using this, I was able to compartment each element of the sky in its own little function. And as we will see, this optimization section, in the optimization section, this really helped creating all the permutations needed to minimize the GPU load. But for now, let's explore one of those function, and to give you just a little peek of the shader code and how keeping it simple can still yield to great results. So let's dive into the blend sun material function here. Okay. So here the sun is drawn procedurally. So that means that the function takes the inputs on the left side, and they crunch the numbers, and they draw a glowing circle at a given position on the canvas. Okay. So for parameters, in this case, we can see that the function expects for the orange tabs, the sun position, the sun size, the glow size, and all that. For this pink tab, we are looking for the sun color, and down there we have some masking information if we were to create an eclipse or some other galactic effects. All right. So all of these values are passed down to the drawing function in the middle. So let's dive in. So there it is. That's the function, pretty simple in my opinion, that does all the drawing procedurally with the masks and all, taking into account all the artist's parameters. Okay, I'm not going to explain exactly how it does its job, but what's interesting to see here is that it uses the text chords, so it uses the values in screen space, and this means again that the artist can directly express like the sun or the moon position according to where they want to see it on screen directly. So they don't have to do any math or translate the designer's request to do the job. And so that's a first layer of abstraction in this system, all right, is that artists can work at a certain level without having to care so much about whatever's below. So here's some example of what can be achieved. So bright blue sky, a more foggy, misty day with an eclipse in the background, and some very soothing sunset in a pink sky with the moon rising here. Looks like the party's not doing super well. All right, let's jump into the configuration or how the parameters are being exposed. Okay, now that we know what each component does, let's see how they get their configuration value. So each component that we saw previously has a section in the configuration in which the parameters are exposed. Okay, so for example, the star configuration contains values for the star texture, the intensity, the scale, and the rotation information. Okay, so you can imagine that each section here has similar parameters exposed to control the overall final result. So such parameters can be numerical, so single values, a vector, or a location or direction, or they can be visual as a color or a texture. Now, if we were to use a constant value for each of those parameters, each hour of the day would read the same value, and we would only obtain a static sky as a result, right? So how do we create and store information for 24-hour cycles? Well, this is where Unreal Curves type become very handy. So curves are a visual way to define values for a range. They are really easy to manipulate by artists, and they can contain different types of data. So again, float or vector or color, stuff like that. Let's see an example. This is the curve for the ambient light over a 24-hour period using a color curve. The key moments in the day, like here, are defined by artists with colors, and the RGB values are then interpolated smoothly in between. Okay, this is our 24-hour frame right here. Okay, so we can see that we start with blue night, go into orangey morning, then white light, and then go back to the night. So 0 to 24 here. So when this system wants to know what the ambient light is for a specific time, it simply reads the curve at that given time. So when the time increases continuously, then the changes in the ambient light follow the curve data, and the result is a smooth transition between the artist's defined colors over time. Okay, another example here is the moonlight intensity. So again, we have our 24-hour frame, and we can see that the moon is mostly present during the night, and at 10 a.m., then it would be completely invisible. Now let's see a positioning example. So this is for the sun position. Again, the 24-hour frame, and we can see the sun Y value moving up and down. That's the green line during the day. And the X value, it's an increasing value on the red line, which is moving the sun from right to left in our case. Okay. All right, that's great. But now how can we store gradient information for the sky background colors? Okay, this is too much information just to store in one curve. So in this case, we use a small texture and associate each pixel column to a time in the day. The left side is the texture of the texture is midnight. Then the middle is going to be noon, and the other side, the right side, is going to be midnight the next day. Okay. So for a given time, the shader reads the corresponding column of pixel, which is used as a gradient for the background on the whole canvas. So it's being stretched. Okay. So fun fact here is that those textures are only 32 pixel wide. So very light on the package size and in memory. Okay. This is probably the size. Since shaders can read between pixels, so between those columns, it interpolates the colors for free, and we get smooth, continuous gradient change over time, even though the resolution is very, very low. So that's one optimization here. Okay. Once artists are happy with their numbers and their parameters and everything, they can save complete sets of values in the configuration. Okay. Many configuration can be defined, and they're all contained in a single data table. So this is the table, and each row has a distinct configuration. Okay, so all of these define different sky looks. There you go. All the configuration are saved also using a friendly name that the designers are then going to refer to build up their scenarios. Designers don't have to know what the values are set in the configurations. They simply want to transition, let's say, to a blue sky or to a stormy sky without, with the minimum input. So that's the second layer of abstraction that we see in this system, is that the designers don't have to know about what the artists have been doing. They just need to know what they're going to get as a result, and they can focus on the story. All right, let's see quickly a full cycle of that all in action. So we see our quad right here. It's got the background changing. You can see smoothly. You can see the stars coming in. We can see the clouds coming in and out. They're also scrolling a bit. What we can see is the moon and the sun changing the role in there, and we see the directional lights following the moon and the sun, and the line that's there is the color and direction of the light. So you can see that at midday the shadows are much less long, and at the end and beginning of the day then we get very long shadows. So again, that's the parameter that the artist can play with. Okay, now let's talk about ease of use. What if I'm in charge of a cinematic and then the time is fixed? Do I have to unnecessarily create curves for each values that each parameter that I want to edit and put a straight line constant value in the curve? Well, no. To make life easier for cinematic lighting artists and to minimize the number of curves in the package, each configuration input also exposes a constant. Okay, so we have those two here. Here's the curve and here's the constant. Okay. The constant is only used if there is no curve being set in the configuration. So as an example, the light intensity here has a curve. So this is what's going to be used, and the constant is going to be completely disregarded. In this example, the shadow length doesn't have a curve. So in this case, we're going to use the constant. So this type of dual parameter makes it very easy to create static skies in minutes, and it gives a lot of freedom on how to use the system, so that's with or without the curves, without having to compromise on ease of use. Right? Let's see a cinematic here. So there we go. So these, so you can see first of all that the sky is a static sky. Only the clouds are moving slowly just to give it a bit of life. But yeah, those scenes are very interesting. I mean, each time the player gets to a location in the game, they can choose to stop and replenish and revive and stock up on what they need. And we see an animation, I mean a cinematic like this, entering the location. So it gives you a good idea of what's going on in there. I think it's very pretty, and there's a lot of good art in there again. That's why I like to show you. All right, moving on. So we're getting to optimization section right now. So that's all about keeping production happy and also keeping production off my shoulders. So great. Now we have a system that makes pretty images and that the artist can abuse in many ways. All right, so job done, right? Well, sadly, no. Without a good understanding of what's going on under the hood, it's very easy to overpower a system and let it drag the most recent devices in the mud. Okay, so let's now take a look at how we optimize the system and keep the oil flowing while the gears are grinding. Okay, to optimize the performance of a video game, one must offload both the CPU and the GPU. Sometimes one or more than the other, depending on which one is the bottleneck, but it's always good practice to keep the code execution slim and light. In this case, here's how each of those processing units were treated to minimize their workload. Okay. So the CPU optimization, we're going to see how we optimize the system update. And for the GPU optimization, we're going to see how we reduce the material complexity. It's probably good to mention that the Oregon Trail, being on Apple Arcade, is played through a vast range of devices types. So all the iPhones, old and new, the iPads, tvOS, Mac. So all of these need to be accounted for and tested thoroughly. All right, so let's start with CPU optimization. So while doing some profiling using Unreal Insight, and that's looking at how much time each function in the code takes to execute, we quickly found that reading all the configuration parameters and updating each component of the system was taking a lot of time. Okay, so this is the whole, the whole optimization process. Just letting you know, those numbers are from PC, so it doesn't really mean anything here. It became very clear that updating every component and all of their parameters, every frame was a very naive way of getting things done. So we needed to be smarter than that and find a way to turn off some of those updates when they weren't required, right? So for example, in this scene, let's say that's a daytime scene. The moon is not even visible, and we're still doing the update on the component and reaching for all the parameters and then passing them on in here to the material. So we're spending a lot of time doing all this for nothing, basically. All right. So let's see how we solve this. So the first step was to add an active parameter to each component. Okay, so this means that the artist could then turn some part of the image on and off if they needed. Okay, for example, the stars parameter update can be turned off during the day, or the clouds can be turned off if it's a bluebird sky. So right there, we could see improvement in the performance, and this proved to be a good solution. But now the issue was that the burden of keeping the system optimized falls on the artist's shoulders, and that becomes a bit counterproductive when the artists are trying to keep focus on making things look good. So the second step to this task was to automate the process. This was done by identifying a subset of parameters that would make a decision for us to set the component active or not. Okay. For example, if the opacity of the moon is set to 0, right here, on a given frame, then there's no need to read more of the moon's parameter, okay, like the color or anything. We don't need to update the component, and we don't need to pass on the values to the material to update the material. So for each component, we implemented an early stage in the update process that would only read those critical parameters from the curves and decide if the rest of the update can safely be skipped. The great thing is that even if the active parameter is not driven by code, even if it is driven by code, it can be still edited by artists if they want to keep a tighter control on the execution of their skies. So going back to Unreal Insight for a post-optimization profiling, we find that the moon update time is greatly reduced. So this is only doing the pre-update thing. And we see that there's no update for the material either. So good job, everyone. Yeah. So that's CPU optimization. For GPU optimization, what we're reaching for is to minimize the shader cycle count. So we do this by simplifying the material graph. Okay, if you remember this graph, this was the material with all the material functions. And so all of them are doing the job right now. So as we saw earlier, each part of the image is drawn by one of those functions. And the problem is that even when one of those parts is not requested, okay, for example, the sun is not visible at night, the shader doesn't know. And even if the CPU sun component on the CPU side is not active, the GPU doesn't know about this. And it will still execute code only to draw nothing at the end. So not very efficient. In order to avoid wasting time drawing ghosts, we created all the permutations of the material to support every state that the sky can be in. Okay, so that means that there's one that paints only the sky. We have a material that paints the sky and also blends the sun in it. We have one that adds the stars to that, and we have another one that maybe just painting the skies and having the stars, and so on and so forth. I think you get the point. So knowing ahead of time what part of the image are needed to compose the final render allows us to use the least expensive material for each moment of the game. Not only does this minimize the overall shader complexity, but it also removes the need to transfer unnecessary textures to the video card. Right? And that's how we keep the GPU relaxed at a decent temperature. And this is how we can achieve a steady 30 FPS on all devices. All right, so talking about design and transition to create a story with all those. So now time to give control to designers. And this is achieved through our in-house trail event graph. So with this tool, the designers have access to a list of event building nodes. each node manipulates a character, a prop, the dialogue, or any objects in the game. So it was pretty easy to add a node that controls the sky and let the designers load one of the configurations that was previously carefully curated by the artists. So the first parameter that you see in the box, which is right now the type, this is the list of the friendly names that we saw earlier in the configuration. So they simply have to choose that and a transition time, and that's how they get a transition between the skies. Okay. Of course, this required the support transitions to smoothly go from one configuration to the other. Okay. This was achieved by reading both configuration at once, okay, the from and to, and gradually blend the values together, and then feeding the result to the material and other external parts. So all of this is done under the hood. Designers don't have to deal with that. But with such a high-level abstraction to define the sky looks and lighting moods, the designer can then focus on the story, and they can simply call on a stormy configuration that they know will react to any time of the day to start and tell a story, let's say about that time when the party got stuck in the rain for multiple days and nights, they almost died. Or they can bring up a majestic rainbow that is coming out of the fog over bright blue sky to let the party know that everything's going to be fine from now on. Probably not for long, though. There's always trouble on this trail. All right, time to put all this together. So let me show you the trailer of the game. I think it's interesting to see it in action also, because now you can see the sun moving across. You'll notice also some stuff we didn't talk too much about, but which compose the image nicely, which is the lens flare. There you go. All right. Hope you appreciated that. All right, so we're getting towards the end. I hope you could learn a thing or two so far. So let's recap the good practices that were applied in this project. I encourage to apply them on your own work if you're in the tech art field like me, but otherwise request them, because that's gonna make your own life better and your teams as well. Okay, so here are 4 practical takeaways that you can apply to your work. First one, try to centralize parameters into a one-stop shop. Okay, in this case, we have the configuration that just assembles all the parameters in one place. So this avoids that the artists have to jump all over the place to find different parameters and different components. Try to use simple input parameters, types, and names. This is all about predictability. I think that a parameter name should tell you exactly what you expect it to do when you change it. Okay? So the sun color should be called the sun color, the sun size should be called the sun size. Seems trivial, but when you're from the tech side, sometimes it's very compelling to name this the radius of the circle thing on the screen, and that doesn't speak too much to anyone. Okay? Also, the use of curves made it much easier than punching numbers into a table. Creating levels of abstraction, as we saw for each party involved, helped a lot. So for artists, it's about not caring about what the materials are doing, and they just can provide values in screen space. And for designers, it's all about not really caring about the numbers that are in the configurations, but using friendly names that are telling a story. And then finally, obviously, you need to automate. Well, you need to optimize, that's for sure, but automating the optimization as much as possible makes it easier for you and for anyone. So in this case, what we had is that the complexity of the updates and the material are changing based on the input data. So whatever is being set by artists is going to drive the optimization directly. That helps a lot. Okay. By using these, we keep control on what each party is doing, and we avoid going down the rabbit hole of costly calculations and complex systems. So everything I demonstrated today is pretty straightforward, right? Well, I believe it should, because I strongly believe that simple is good. So you can take that away. All right. I think we've covered everything. I would just want to go over some fun facts, and then we can go into QA. All right. So what you see here is our dev team that was turned into animated GIFs by our talented art team. I thought this was great. We have T-shirts of this as well, so that's pretty cool to see yourself as an animated GIF. Simply to show you that even if this was our first game developed under Unreal Engine at Gameloft Australia, it's been a breezy production, and I have to admit, a very good experience. So we had time to learn the tools and achieve a lot in the time that we had to deliver this game. So that's an example. I mean, this is not part of the game, but it's a great on top thing. Little personal story about that. We had a recurring bug in the game at some point, which was that one of the characters would come up very, very small, and nobody placed it there, but it was just showing up randomly on the trail at some point, like behind bushes and in the trees sometimes. So nobody put it there. It was just that mini-me guy that would just show up, and he became pretty famous because fixing that was a bit mind-boggling, but it was also fun to see him pop up on the trail here and there. So once we had fixed that, I had a bit of time on my hands, and I was thinking of trying to do an Easter egg where it would generate the same bug but controlled, where the mini-me guy would show up sometimes on the trail, different location, different times, and would not come back at the same place, same time. And so that would have been funny to put that back in. But obviously, using my professional judgment, I did not do that because that would have put a lot of stress on QA, I guess. And yeah, so a lot of fun developing with Unreal and developing the Oregon Trail. All right. On this note, I am going to leave you with some images of the beautiful locations that the cinematic give you. That's the player encounter on the Oregon Trail. All of these were lit using the time of day system that we talked about today. And you can see that they show very, very different ambiances and time during the day and night. A lot going on. Great moods. Great art. So yeah, lots of great things to see here. And there we are. Congratulations. We made it to Oregon today. So that's the end of our journey. I want to thank you for tuning in today. That's a very pleasant experience. I hope you enjoyed this presentation. You learned a thing or two. And I think we will now go into a QA session. Thank you, everyone. All right, so I guess I'm ready to take questions that are on the site. I'll try to see this. Is that the main way that this is going to be doing? Okay, I have a yes. So I'm going to try and read those. Okay, so Hannah is asking, was there any performance reason for using separate materials for the sky instead of using static switch parameters or material instances? Yeah, great question. So when this was first introduced, it was not in a panic, but I would say it's just that I realized that the material had to be modified. I didn't have much time to see how I could do this otherwise, but I realized speaking with people now that there's many ways of doing this. The reason I didn't use instance though is because yeah, that would have been a great way of doing it, but the reason is that these material need to get parameters on the fly. They are dynamic interface materials, and they're created by code. So this means this can only create a material. and then we feed the parameters. An instance is data, and that's being created, and the parameters are already there. That's what I know about it, so that's the reason I didn't go with the instances. But yeah, hope this answers the question. There are many ways of doing this though, and if I was to do this again, I would definitely search a bit more, because doing permutation is a solution, but then if you add more, then you end up with a very, very big number of materials. Okay. Jeff is, sorry, Simon is asking, what was causing the bug? The bug. I'm not exactly sure I know which one you're relating to. If you can specify, I'll come back to it. Jeff is asking, how do you handle edge cases when artists visually want to have something that does not fit into the system but is only used once? So, good question, because there's always like what the system was meant to do, and obviously the problem is that there's a lot you can do with this, and then there's always someone who wants to, I want to branch out, I want to see what I can do with this. What we did in this context, we were lucky enough that the design was done and the concept were pretty strong. So it was good for us to know exactly what we're going to be doing and what kind of solution, what kind of problem we're trying to solve. So the tool is quite wide and broad. Then when there was, and we started small just to see, is that answering the question here? Is that solving the problem? And then adding, making sure that the core is always strong. So for edge cases, these came in those iterations. So I saw that, someone wants to do this, or someone needs to control on that. I'm gonna add the fog. I'm gonna add this and this. And then using the same system, once you know the recipe, it becomes easier to add more of these. So I think that's how we handle the edge cases. There was a bit of debate on if we could move the camera up and down at some point, and that's where, you have to weigh the pros and cons and say like, well, if we do this, we're going completely out of the context here. So do you really need this, or can you solve this problem with another solution? So it's always debating if the change is needed, and if it's going to be, even if it's one-off, even if it's one case, sometimes it's worth adding, because the whole structure is already there, so you can build on top of it if it's well done. If it goes too much out of the context, then maybe try to find a different solution. So this. All right, so I have clarification on Simon's question. So yeah, the bug that we're talking about being a small person. I don't, to be honest, I don't recall what the bug was. I think it had to do with some data, or it was contained within an instance that was referred by another blueprint that had it, that was created on the fly. So it was really hard to follow the trail and see where that was coming from. But yeah, that was the mini-me bug I was talking about. Seriously, I don't recall what the origin of the bug was. I just know how I could recreate it though. Yeah, make it fun for probably just myself though. So let's jump to another question. So Bats is asking, does the time of day system also interface with weather effects like wind and rain? Yeah. Very good question. My intention was to talk about this in this talk as well today. Because yeah, it's very tightly coupled. You can imagine the VFX that are put in front of the camera. So yeah, the winds and the rain and some more effects in the front. They are tied to the system. It's a different blueprint, so it's not within this one, but they speak together through events a lot. So when we are calling a certain configuration, and it includes rain or something like this, then it talks to the weather system, which starts a pack of VFX and post-process events. So yes, they are very tightly coupled, and you can imagine the system working pretty much the same way. It's just a different blueprint that we didn't cover today. Okay. Hannah is asking, have you compared the shader permutation cost of different materials versus the added render cost of its statement with a single shader? Do you compare the shader permutation? Okay, so what I understand here is that, let's say I have one Uber shader that does everything, and I'm switching materials in the context. So comparing the cost. Yeah, the overall cost. So that's how I understand the question, so I'm gonna answer that. So if we had an Uber shader that does absolutely everything, and the system that we have here where we switch materials, the rendering cost is much less for one that's small. Obviously, if we have a material that does almost everything, yeah, there's not much saving, but shaving everything is sometimes the way to get the most out of your application. The thing though is that at first I was loading these material on the fly, and this had a cost because you have to create the material and then bind it and everything. So what I did is I created a cache because those materials are bound to come back. There's probably 20 of them, and so once we create one, it goes into the cache and it's ready to be reused right away. So between frames, once they're all there, or if there's a new needed, it just adds. It's just this one frame that's going to be loaded and take maybe a bit more time to get things going. But once this is done, switching from one to the other, that's not very costly, to be honest. So it did the job. It did the job right. Again, there might be some other ways to do this, but that's for future talk. All right. More questions. Yeah, Hannah was asking, was your ambient light handled by a skybox with captured scene cube maps or with a post-process ambient cube map? So Unreal exposes the way to have your ambient light calculated by putting a scene capture in the middle of your scene, and then it renders everything into a texture, and then from there you can extrapolate or evaluate what the ambient light would be. So to give control to there's two reasons we didn't do that. The first one is that I want to give control to the artist, and I want them to be able to put whatever color they want. If they want to have a directional light that's blue and an ambient light that's green, I don't care, that's what you want to do. So I've exposed those values. So the ambient light color is one curve, exactly like the rest of the parameters. And so people can choose to set the ambient color that they want. Because the game has a bit of a toony look, I don't like saying this because we're not going for a toony look, obviously, but just saying that the material, the lighting is still, very straightforward. Ambient light, directional light, and shadows, and that's how you get the very basic lighting. But exposing the good parameters and choosing the right values, that's where the real trick is. The second reason we didn't do that is that because we don't have a full 3D environment, okay, you can imagine that the trail is there, and then there's a background, and then everything else is black, okay? If you look at it from a third-person view. So what would happen is that even if we captured this scene, we'd end up with a lot of black around, so the ambient color would not really represent what we're looking for. All right. All right, so it looks like most of the questions were around the materials and the material instance, and I see where your questions are coming from, because that was my first initial reaction. I want to just create instances and make them do exactly what I want and just load them. But like I said, it was not possible because it needs to be an interface material created by code, which instances are not part of, from my knowledge. Maybe I will be learning something new very soon. But yeah, so I think that was the main thing that people asked around here. So yeah, I think we're at the end of it. I really want to thank you everyone for logging in today. That's great. I really enjoyed this. If you have more questions, you are very welcome to write to me at these addresses over there. So Bruno Gohier at gameloft.com. I'm also on Instagram at Bruno Gohier. And this was me, Bruno Gohier from Gameloft Australia, talking about lighting the Oregon Trail in 4 dimensions today. Thank you very much, and hope to talk to you next time. See ya!